Wonderful, thank you. All right, hello everybody. Welcome to our last class in this series of PBCore webinars. Today we're going to be talking about basically applications of PBCore outside of the individual records themselves. We're going to be focusing on PBCore mappings and database modeling, but we are going to take a couple of detours into some of the tools that have been built to help utilize PBCore in real-world contexts. That's going to take about half an hour. Then we're going to take 15 minutes to talk about a case study that has been kindly contributed by a member of this class. And we're just kind of talk through that and some of the ways in which you would utilize PBCore in that context. And then for the last 15 minutes of the class, I will just be here to answer any questions, go deeper into anything from this session or any of the past sessions that people want to go over again, and just kind of take advantage of the opportunity to review content. I'm going to give you a warning in advance. I'm not an expert in building databases. I've consulted on the PBCore end for a lot of mapping and database projects, but I don't build databases myself. So if you have a specific question about database builds, I can't guarantee that I'll be able to answer it. I do kind of want to give a general overview of the concept of how you would apply PBCore kind of underlying a database that you'd utilize in production though. And I am going to show some examples of how we use PBCore in databases that we've built here at GBH. So that's how we're going to run with that. And even if I can't answer a question, it's entirely possible that someone else in the audience can. So I encourage you to pitch it anyway. And if there's something that I don't know, then we'll learn together. Once again, I'm thankful to Northeast Document Conservation Center for hosting these webinars and National Endowment for the Humanities for funding them. And PBCore was originally funded by the Corporation for Public Broadcasting and is currently overseen by GBH, which is my place of employ. So let's start by talking about metadata mappings. What is a metadata mapping and why is it important? This may be a review for a lot of people here, but just to kind of emphasize why we're talking about it and why I want to use that as an entry point to start talking about databases and broader applications. So one example of why you might want a metadata mapping. Say a public media station is closing and wants to donate their materials to a local university library. The public media station has been cataloging their materials in PBCore, as many public media stations do, but the library's catalog is in MARC, as I'm sure many of you have been familiar with if you've worked at libraries. If the PBCore fields are mapped to MARC, the library can write a program to transform the data and ingest the records into the catalog system. They just need to know how to put those fields that are originally in PBCore into the fields that MARC utilizes and recognizes. So that's kind of a traditional metadata mapping example. You have two standards. You would like to understand how to translate one standard to the second standard. For a second example, say an amateur filmmaker has donated their home movies to a local historic society, and the filmmaker has a personal system to keep track of their output, and the historical society uses PBCore to catalog moving images. If the Historical Society creates a mapping from the donor system, they can transform and accession their metadata. So this is maybe a little bit of a less traditional usage of a mapping, but in fact, one that's really common that I'm sure you've seen something similar. We've all seen something similar where you're accessioning or you're trying to create a relationship from something that isn't necessarily a formal standard or isn't a standard that has a website or is widely utilized in the library or archives community, but absolutely has an underlying logic to it and an underlying, set of fields and set of information. And you want to try and translate that information into something standardized so you can accession it into a collection. That's also a kind of mapping, and is also, a way to, it's basically a way to take a set of data that's represented in a way that one system or organization understands and move it to something that's broadly understandable by the system or organization that you currently are using and are tracking information in. So the same data can be expressed in many different ways. And I wanted to demonstrate that by kind of taking a quick detour into one of the tools that we have that uses PBCore. So this is an example of a tool called MediaInfo, which some of you may or may not be familiar with. This is a tool that allows you to take any media, audio or video file and run this tool, and it will spit out a list of all of the technical characteristics of that media file. So this is kind of the native output of MediaInfo. And if I ran it here in the example on this slide on a particular MP4 file, and it told me the format, the file size, the duration, the codec ID, the width, height, the frame rate, et cetera, all of those kind of technical terms that we went over in the first class. But this is kind of MediaInfo's own particular output format. This doesn't really necessarily conform to a metadata standard that I might use in an organization or institution. So if I would like to have this data expressed in a different way, I can run the same command and tell it to do output EBUcore, and it will output the same data structured as EBUcore data. Or I can tell it to do output PBCore 2. This is PBCore 2 because it's PBCore 2.0, which is the most recent version of the standard. And it will output that data structured as a PBCore instantiation. I'm going to duck out of my slideshow real quick just so I can demo what that looks like live in case that's something that any of you guys would like to use in future. Always a risk with live demos, but here we go. So if I have a terminal window open and I want to run this on a file and I want to find the technical characteristics of that file, in order to get just kind of the standard MediaInfo output, which doesn't conform to a specific standard except MediaInfo's own, I'll just type MediaInfo, and then I would drag and drop a video file that I happen to have on my desktop. Let's take, grab one. Here we go. So here's a media file, and I drag and drop it. And it outputs technical metadata about that file. It tells me it's an AAC audio file, 48 kilohertz, 2 channels. It's a lossy compression. It's got a time code channel. Here's the video. It's ABC. And here's kind of the data specifically about the overall container of the file, which tells me that it's an MPEG-4, tells me the duration, tells me the overall bit rate, et cetera. This is all useful information to know if I just wanted to look up a piece of data. But if I wanted it output in PBCore, I'd do that same command, that MediaInfo to the file, but I'd add output equals PBCore 2 to my command. And now I get the same data structured as a PBCore record. This is actually a really useful way to kind of look at a PBCore instantiation document as well, because you can see that everything that is structured, the file name goes in identifier field with the source file name, the date and date type, file modification date, instantiation digital is properly structured as video/MP4, and all of this data that maps neatly into PBCore is structured within a PBCore field. But MediaInfo also has a number of fields that don't map neatly into PBCore. And for these fields, MediaInfo puts these in annotation and adds an annotation type describing what the data is. So for example, PBCore doesn't have a specific field for frame count, which is the number of frames in a video. So MediaInfo, because it provides that information and because it wants to make sure that that information is able to be presented in PBCore if someone wants to use this tool to generate PBCore technical metadata, puts that in an annotation field, essence track annotation, describes the annotation type as frame count, and then lists the data. So this is a great example of a metadata mapping that a tool does for you. And I think it's something worthwhile to look at when you're thinking about how to map metadata into and out of other contexts. I'm going to jump back to my presentation now. If anyone has questions about this while I'm doing so, this is a good time to drop them in the chat. All right. So what does a metadata mapping look like when you're kind of doing it in a theoretical sense? So this is what I just showed you with MediaInfo is the output of a metadata mapping. But when you're actually performing that work, how does that look? Here's an example of a simple mapping between PBCore and Dublin Core. And I'll jump over in a little bit back to our website and show you we can actually download the full version of this. But traditionally speaking, when you're doing a metadata mapping, what you'll see is a spreadsheet that has columns for elements for the one standard and columns for properties or elements from the other standard. And they'll outline, they'll align to each other. In this case, PBCore asset type has been mapped to Dublin Core type. PBCore asset date has been mapped to Dublin Core date, et cetera. etc. So that's kind of the simplest version of a mapping between one of the simplest standards, which is Dublin Core, and PBCore. For a more complex version of a mapping, you might get something like this. This is a mapping that was created by IPTC to map various audiovisual metadata standards to their existing properties that IPTC has listed as kind of the properties that they consider, which is to be important in tracking video news. So IPTC is an organization, the International Telecommunications Council, I believe, Press Telecommunications Council, that tries to standardize news media information as it's exchanged around the world. And because they work with organizations in many different countries using many different tools, in order to create a standard set of properties, they went ahead and mapped to a whole bunch of standards, including EBU-Core, XMP, their own JSON formatted standard, MPEG-7, and PBCore. And you can see all of these, how these properties relate to each other and which properties are contained within all of the standards that they tracked and which are contained within only some of them. And again, I can jump to this when we start walking through all of the existing mappings that PBCore supports in a minute. The important thing to remember about metadata mappings is that they should follow logic that can be understood by a machine. The idea is, as much as possible, to make computers do the work. So ideally speaking, when you're moving metadata into and out of different systems and different standards, you're not going to be standing there looking at your mapping and sort of hand moving one property to another, because generally you're going to be dealing with thousands of records, and that's not really the way you necessarily want to spend your time. Instead, what you're going to want to do is provide a list of instructions to a computer that can take a bunch of records at once and can interpret those records and transform them into something different. So here's an example from our MARC mapping, which is a very complicated mapping because MARC is a pretty complicated standard. And you can see that for PBCore subject, there's one general mapping that we created, but if subject type is specified, because MARC breaks down subjects into different fields based on what kind of subject they're talking about, whether it's a keyword, topic, personal name, or corporate name. In MARC, many of these go to different fields. So if the subject type is specified as keyword or topic, this would go into a 650 MARC field. If it's specified as a personal name, this could go into a 600 MARC field, and so forth. And so that's an example of something where if you were feeding a bunch of PBCore records to a computer and you were saying, all right, we want all of these PBCore subjects to be turned into MARC subjects, the computer would look through and see if a subject type was set for those PBCore subjects, and then it would be able to move the contents into different appropriate MARC fields. So the existing PBCore mappings, and I referred to a couple of them already, are PBCore to MARC 2.1, premise to PBCore, PBCore to Dublin Core, PBCore to EBU-Core RDF, and the IPTC Metadata Hub one that I showed you before. I'm just going to jump out of my presentation again for a second because you'll get a better view of these if I walk through them on the website. So here are PBCore's existing mappings. And all of them have none of them are perfect mappings, right? Because you can't do a perfect mapping from one standard to another. Otherwise, those standards would be exactly the same and there'd be no point in having two of them. So our MARC mapping is highly conditional and will require a lot of specific logic to implement in full. That's why we have not just an Excel spreadsheet mapping for this, but also pretty complicated associated documentation. We don't provide recommendations for converting from MARC 21 to PBCore, but this one-way mapping, which goes from PBCore to MARC, could be used as a guideline. The PBCore and premise mapping, so this is really a set of instructions for how to use these standards in conjunction with each other rather than a mapping from one to the other. Premise is kind of covers a different set of fields and information than most of PBCore does. So what we have for the PBCore and premise information is documentation that not just does mappings between the premise entities and PBCore root elements that do overlap with each other, but implementation options for using premise and PBCore together, because premise is intended to document preservation activities, and both of them are standards that support wrapping one set of metadata within another. Dublin Core's limits and lack of a notes field in particular mean that it's kind of a lossy mapping to go from PBCore to Dublin Core. It's frequently useful because there are a lot of tools and applications that use Dublin Core as a basis. But when going from PBCore to Dublin Core, it's important to understand that not all the information is going to be able to be conveyed. And that's something in general to think about when you're doing mappings, is what kind of information is going to be lost if you're going from one to the other. Is there a way to ensure that all that information makes it across smoothly? Finally, this PBCore EBUCore RDF mapping is actually a bit of, so to give a bit of context, EBUCore RDF is a standard that has sort of really embraced moving forward to RDF linked properties. And a couple of years ago, because PBCore and EBUCore are similar standards, when we were discussing whether we wanted to implement linked data and RDF properties within PBCore, the decision was made that instead of doing that work, it would make more sense to direct anyone who was interested in using this kind of audiovisual metadata in RDF towards EBUCore and just create a mapping from PBCore XML to RDF. Because RDF is not hierarchical, and because RDF is a metadata, a way of thinking about metadata that encourages properties from different standards and supported by different organizations to be used, this PBCore EBUCore mapping actually incorporates properties from EBUCore, Dublin Core, DC terms, etc. And we're going to come back to look at this one a little more when I start talking about databases. But for now, let me jump back to my slideshow. So that's the basic concept behind doing a metadata mapping from one standard to another, and those are the ones that exist for PBCore. But how is modeling a database to a standard different from mapping between standards? So when you're mapping between standards, what you're deciding is which XML elements or metadata properties correspond to other elements or properties. This can be more or less complicated based on the complexity of the standards, but you're really just thinking about how you're labeling data. When you're modeling to a database, you're not just thinking about how you're labeling data, but you're also thinking about how you're organizing data. So when you're modeling to a database, you have to not only decide which XML elements and metadata properties to use as fields in your database, but you also have to think about what type of data can go into those fields. You have to decide how those fields will relate to each other and decide how to design and label those fields for the user. So I mentioned that I was going to come back to this PBCore to EBUCore RDF spreadsheet, and we have linked under that particular, on the website, linked under our mapping, we also have an example modeling spreadsheet that we used in the American Archive of Public Broadcasting when modeling data for our AMS2, which is the data organization system that underlies our public website. And this kind of shows how we thought about each field in PBCore as it was going to be represented in that database, which is based on a data model that uses RDF. So some things to note when looking at this example is that there's a difference between the name of the field as it will appear in the database and the underlying PBCore property. Sometimes the same PBCore property, such as PBCore title or PBCore identifier, may end up broken down into more specific fields within the database, as in episode title or program title, to make it more user-friendly and to help people find what they're searching for. And you might see that like a PBGUID and local identifier are both represented here in the database because we're going to want to track those identifiers separately, even though they both use the underlying PBCore identifier field. And then we use attributes such as source to actually map to a property when it's going in and out of the database. So changing the fields in this way doesn't mean the database isn't PBCore compliant. It just means that PBCore has been adapted to the needs of local use cases. The goal is to make sure that PBCore data can be imported and exported, even if what emerges in the end is not strictly PBCore metadata when you're looking at it on the screen. You should note also that this spreadsheet specifies what kind of data should go into the fields for our institutional use case, such as requiring controlled vocabularies for asset type or genre or topic, and how the fields should be indexed within the database, as well as how they should be presented. Like I said before, I'm not going to get too deep into data indexing strategies and how they work here, but I wanted to give you a sense of the kind of decision-making that goes into database design. And once again, I'm going to pause this for a quick moment to show you how this data modeling worksheet appears. It's actually longer than I was able to fit on the slide, and how it then jumps to the RDF property that's being modeled underneath. And It has section headers for how this is going to be presented in the database. It lists range, and it has, kind of a discussion field for when we were doing this modeling. And if you want to look at this as an example, you can find this under the PBCore XML RDF section of our website. Does anyone have any questions while we're jumping back to the slideshow? All right. So to go back to an example that we've used previously, you remember when we were talking about Star Wars: A New Hope and the different title types that were associated with it. If you're working in one PBCore record, you would just assign a title, and then you would say the title type is original, title type revised, title type alternate, et cetera, et cetera, et cetera, until you listed all of the different kinds of data that you wanted to use to refer to this specific record. But when you're working in a database, you have the opportunity to work on multiple levels. So within a database, for example, you might have a record for the series. That series title, that series record would say the series title is Star Wars, and you have a description for the Star Wars as a series. And then you might say the subtitles within those series are A New Hope, The Empire Strikes Back, and Return of the Jedi. And then you might have a record for on a different table that lists programs. And in that record, the program title would be Return of the Jedi. You'd have a description for the program itself, and you would be able to link between those tables based on the unique ID or association between Return of the Jedi, this program title, and Return of the Jedi as it appears as a subrecord of this series, Star Wars. So when you're thinking about cataloging within a database, what you really want to think about is not just how to get all of the information that you need in one single record, but how to create records on different levels that contain that information and can be linked together, and crucially can then be imported and exported in such a way that it preserves all of the data associated with that one record. I do want to take a quick minute to talk about different types of data. This is kind of a throwback to when we were talking about controlled vocabularies a couple sessions ago. You can have, uncontrolled data in a database. Anyone can put any kind of data in the field. It will be unstructured. This might be good for a description field that might require many different formats. You can have a controlled vocabulary, which will usually be seen in a database as a drop-down list that's populated by the institution creating the database, so that people who are using that database and filling out data understand what the restrictions are and select from a list of valid terms. You can have a formatted date field. Any date field should be constrained to the date formatting that your organization wants to use to ensure consistency throughout. Generally, in PBCore, we recommend the ISO date standard, but obviously it can conform to whatever your institution wants to use. But it should be structured so that, again, a computer can understand it, so that you can run operations like figuring out what was done before, which records are your earliest and which records are your latest. If your dates are inconsistent, your computer won't be able to understand that. You can have a text or a string. These are actually two different subtypes of fields. But the data in this field may include letters, numbers, special characters, the dash symbol, and the number sign, and will be, if it's a text field, and will be interpreted as text by the database. For simple data fields like title or identifier, it's often a good idea to constrain it to a string to avoid formatting complications. I'm sure all of you have had an experience of trying to move data from one system to another and finding that weird formatting or special characters get parsed in a way that the new system can't understand. And it makes your data look unwieldy and maybe unintelligible. So this kind of constrained formatting does simplify when you're moving data that's in records from one computerized system to another. Finally, sometimes you might want to constrain to a numeric field. This can be helpful to ensure the database can run calculations like total file size across the collection. If someone is filling out file size records in totally numeric terms, and someone else is writing out 3 gigabytes to describe how big the file is, the data, your system, when it wants to run that calculation, is not going to be able to include the spelled out 3 gigabytes in your total of how much data you have, which is going to throw your assessments off. But the most important thing to think about when you are, oh, I see, I have a question about the difference between uncontrolled and text string data types. Sure. So text and data types and string data types have a pretty limited subset of kinds of data that can go into that field. I realize that letters, numbers, special characters, the dash symbol, or the number sign seems pretty broad, but there are certain kinds of entries that will not be, included necessarily in that subset. And also, in various computer systems, there are terms and phrases that you can use that are not meant to be interpreted as text. When you specify a field as text or as a string, what you're telling the database is that I just want to look at this as text no matter what. I don't want to look at any special formatting. I don't want any code to be interpreted. I don't want anything to be automatically transformed into a date that I don't want to be transformed into a date. I'm sure you've all had this experience in Excel where it starts to, you put in something that you want to be read simply as text, and it immediately starts trying to transform it into a date field and reformats it under your eyes. When you specify a type of data as text or as a string, you're saying that I only want this to be read simply as the pure text. I hope that helps clarify a little bit. Just to jump back to the slide here, the thing that is most important when thinking about database construction is that you want to be able to put your data into it, and you want to be able to get your data out of it. And we were talking a little bit earlier about lossy and lossless data mappings. And the same is true with a database mapping as with a metadata mapping. It is possible to put data into a database that can't contain all of the data in the original records that you're putting in. It's possible to have an output method from your database that's not going to be able to output all of the data that your database contains. That's something that ideally you want to avoid. Ideally, you want to ensure that you're constructing your database in such a way that when you're putting data into it, there's going to be fields to hold all of that data in as structured a way as when you put it in. And there's going to be an opportunity to export that data in a similarly structured way so that you can then move it along to your next database system or what have you. The one thing that's kind of a constant in a preservation environment is that eventually you're going to build a database, and eventually the technology that underlies that database is going to become obsolete, and you're going to have to move to a different database or a different system. That's one of the reasons that we recommend PBCore, and if not PBCore, another structured metadata standard, and thinking about these as import and export mechanisms into and out of a system that is, whether it's a database or whether it's a collection management system or anything else that you're using to manage your content, so that when the shift comes and eventually you're going to have to move to a different system, you can make sure that you're using something standardized. And hopefully that next thing will make it easy to map from your database, your PBCore metadata into the database. And with that mapping, you could then use it to export PBCore metadata out again on the other end and still have all of the data that you retained and still have it in that structured methodology. So what matters when building a quote unquote PBCore compliant database is not so much that it looks like PBCore on the outside, but that you can put your PBCore in and that you can get your PBCore out. That's what I would consider to be kind of the most important thing. I'm going to pause here. So that's sort of the end of my programmed lecture. I'm happy I have a couple examples of what our FileMaker databases look like, and I'm happy to walk through those. And we also have the case study that we're going to talk about, which came from Tammy Gobert, Preservation and Access Archivist for Institute Archives and Special Collections at Rensselaer Polytechnic. Thank you so much, Tammy, for doing this case study. And I'm going to exit out and pull up the case study document. But I want to take a minute and ask if there's any other questions or anything else that people would like me to go over before I start talking about case studies and, kind of real world implementations of PBCore. Can the MediaInfo GUI be used to output PBCore 2? Unfortunately, I don't think the MediaInfo GUI currently has that functionality. I believe it's on their roadmap, but right now I think it's only built into the command line application. All right, I'm not seeing any other questions right now, so I'll move on. But if more questions, do you think a future version of PBCore could include track to specify a specific track on an album, tape, etc.? Yeah, I think that's a really good suggestion. Right now, I don't believe we have track on one of the ways in which I would consider breaking down a specific track on an album, tape, etc., is by using PBCore part and using a specific part to specify each track on the tape. But I don't believe we have track on the controlled vocabulary lists, and we really should. So that's definitely something that we should think about in our, kind of upcoming opportunities to broaden PBCore to make it more usable outside of just the public television world. All right, I'm going to move on and talk about the case study for now, but if more questions come up or more things that I forgot to talk about or that you'd like more clarification on, please feel free to drop a line in the chat as we go. So this case study, which you should also be able to find in the class folder, describes a set of films that the Rensselaer Polytechnic Institute holds that documents two athletic teams led by the school's most illustrious coach, Ned Harkness. Due to their age, 1940s and 50s, their content, a lacrosse exhibition game in the 1948 Olympics, 1954 National Hockey Championships, etc., and their value to campus constituents, the institution plans to digitize the collection to preserve its content. The institution then plans to provide access to some or all of the films and/or segments of the films via the library's digital repository. And here are some of our plans and questions regarding this collection. 1, the films are only partially identified, see the preliminary inventory, and we can't view them until after they've been digitized. This is, as I'm sure you guys know and have dealt with, a common problem with audiovisual metadata. We talked about this in the very first class. When you're looking at this metadata from the outside, and Tammy has provided a picture of what some of this collection looks like, all you have, the only information you have is what's written on the outside label, and that information could be a lie. You really don't know anything about what the content is because from just looking at the material. So what's the best way to compile additional metadata about the content after it's been digitized, which will be the first kind of opportunity to actually look at what it contains. The films are in 2 series, hockey and lacrosse, but there's no apparent order within each series. Once we have a better idea what's on each film, we plan to rearrange the collection. The films were somewhat randomly numbered when they were received by the Institute Archives. While we retained their original numbers, we plan to assign new item identifiers to reflect their order after the collection has been rearranged. This will be our first significant project involving audiovisual collection, and we have lots of questions. So first of all, what's the best way to deal with original and new identifiers in PBCore? How much PBCore metadata is necessary, and how much of it can we expect the digitization contractor to provide? How do we link the collection description to the PBCore metadata for individual films and their digital surrogates and vice versa? And then we may host segments of the films on the YouTube channel. Can YouTube utilize PBCore metadata? If so, does it harvest metadata from an XML file, a CSV spreadsheet, etc.? So I'm going to tab over to the inventory of the collection, which right now contains information about box item, general content, the date, as much as could be gleaned, the size of the reel, and some issues on conditions and comments. So this is what the collection looks like. And again, none of this situation is unusual or anything that I think is wildly unfamiliar to anyone who deals with AV. So to tackle these questions one by one, the first one is the easiest. What's the best way to deal with original and new identifiers in PBCore? As some of you guys might remember from when I was just talking about our AMS 2.0 data modeling work, PBCore identifiers are a repeatable field and it requires a source that says where the identifier came from. And it's generally considered that most items are going to have multiple identifiers. So in the AAPB, built into our AAPB data modeling worksheet, we suggested that every item was likely going to have a local identifier from the institution where it originated. And then we were going to assign it a new identifier, that's our AAPB GUID, so that we could track it within the database. Within this particular controlled case study, I would suggest that Tammy potentially have one identifier and label that as the original identifier and track that on each item, and then assign a new identifier in PBCore once the files have been digitized, that sort of reflects the new ordering and the sub-collections or whatever naming schema the organization would like to apply after the fact. The second question is how much PBCore metadata is necessary and how much of it can we expect the digitization contractor to provide? So it's really useful to provide the kind of metadata that this institute has already started to collect to a vendor. It's helpful for them to know the size of the reels when they're starting to digitize them, what the format is, and what the condition is in order to provide an additional, some kind of initial assessment of what that content is going to be and what the cost is going to be to digitize it. But as far as the actual technical, detailed technical metadata about each field, one can expect that the vendor is going to, and one should expect and should ask for the vendor who's digitizing that content to provide a lot of detailed technical metadata as they are going through and actually doing the digitization work. So I'm going to provide a demo of the kind of shipment metadata that we receive for our big digitization projects on a monthly basis from our vendor, most of which is filled out by the vendor. And this is kind of a beast of a spreadsheet, so I apologize. But when we're sending this data out, we provide, the unique ID for each item that we've provided, and we provide a title and we list the format, and then we have some information about what priority it is. And then there's a whole bunch of metadata, including whether the item was baked or cleaned, what the actual runtime is, which is something you can't know until you start to digitize it, what kind of audio tracks are there, whether there's closed caption metadata, any additional migration notes, how it was, what machine it was transferred on, and so on and so forth. The file size of the digital file, all of which is provided back to us by the vendor as part of our contract with them. And you see that this is not, structured necessarily in PBCore. This is provided back to us in a spreadsheet with the fields that we'd like them to fill out. But then what we want to do when we're creating that spreadsheet is we want to make sure that it can then be ingested back into a database that can be linked to the content metadata that can be added when we review that item back in our own institution. So I'm going to provide another demo here. This is a database that we use to track a digitization project here at GBH. And this is based on PBCore. Again, it doesn't look like PBCore necessarily on the front end, but all of these fields map to PBCore fields on the back end. So we receive technical metadata back from a vendor, and these are the fields that map to the technical metadata fields that we receive back in this spreadsheet. And when we receive these spreadsheets, we import them back into the database that contains all of the technical metadata fields. And then, so this is one table of this database, and this table is just, just referring to the digitized items, the technical metadata regarding the digitized items. And then that technical metadata gets pulled into this production level table view where we do the cataloging as we actually review the digitized materials now that we have the opportunity to play them. And that's where we start to apply PBCore terms like subjects, creator and contributor, location, so that's, that would map to coverage, description, asset type, etc. So this is where we actually do the bulk of our cataloging work. And that's how, we can then export to PBCore records from this particular database. And that export will pull in all of the instantiation level metadata from this digitized items field, as well as the content metadata that's created once we actually have the ability to catalog these materials. And then we export it and it goes out to, this field shows the items that have been exported and made available through Avalon, which is kind of our internal viewing page. So that's one way that I would recommend to answer this question of how to provide, how to handle how much PBCore metadata is necessary and how much of it can be expected by the digitization contractor to provide. Generally speaking, the digitization contractor is not going to provide a lot of content metadata, but they are going to provide the technical metadata. And as long as they provide it in a structured and standardized way, you can then organize a tool so that that structured and standardized metadata, which could be provided in a spreadsheet, it could potentially provided as you know, PBCore instantiation, like that MediaInfo report that I showed you earlier. It could be provided in any way that you can work with within your system to then incorporate within a PBCore record or a system that, you know, can map to PBCore fields or a database or however you want to do that cataloging work, to incorporate, to marry the technical metadata that the vendor provides and the content metadata that you as an institution are going to be able to provide after the fact when you're reviewing the digitized materials. The next question is, how do we link the collection description, Dublin Core metadata, to the PBCore metadata for individual films and their digital surrogates? This is another really good question about kind of data modeling, right? And I'm going to jump back for a second to this very, very simplified, actually, instead of jumping back to that simplified slide, I'm going to show you an example from one of our other databases, which is the one that we use to track content within WGBH's collections. So here I have, this is a beast of a database, so I don't necessarily expect you guys to intake all of the fields of the way it's structured here. And I don't expect anyone else's databases to look like this. This is a legacy database that we've been using for a long time. But this database is structured on multiple levels. The highest level is programs, projects, or what in this particular use case that we're talking about, you might call a collection. And on this level, for example, I might have a record that describes the eyes on the prize overall project or overall collection. And underneath that, I can link to the records for all the related material. And by jumping there, you know, I can say, all right, we have all of this promotional material that's related to the Eyes on the Prize collection. I can open up this record, and that will provide me a more detailed view that has, again, these fields mapped to PBCore underneath, more detailed descriptive information, item type information, and technical specifications around this particular item that's associated with the high-level collection. So again, when you're thinking about how to present your material and how to link your material, it's not really necessary to have, you know, if you have collection level records in Dublin Core, that's perfectly fine as long as it maps to a standard. You just need to be able to have a linking key that says, all right, here's my Dublin Core record. I am linking that Dublin Core record to the PBCore metadata for individual films within my database. So this particular record has a relation to, and both Dublin Core and PBCore have related relation fields that allow you to link one record to another record. And you can figure out a way to replicate those relations in your database. And as long as you can draw those links, as you can say this record is related to that record by saying perhaps is part of collection, then you can replicate that in whatever way you're using to review that data and draw those connections and map from, you know, the Dublin Core field to the PBCore field and vice versa. This final question, we may host the films or segments of them on RPI's YouTube channel. Can YouTube utilize PBCore metadata? So the answer to that is no, YouTube can't utilize PBCore metadata, but it does have a CSV ingester that you can use to batch update metadata. It actually has a couple different varieties of CSV ingester. And while these don't specifically use PBCore fields, and I'm not going to, you know, go through all of YouTube's CSV ingesters right now, but again, you can use the principles of metadata mapping to look at the fields that are provided within YouTube CSV ingester and see how those fields align with PBCore metadata fields, with the elements of PBCore, and how you would map from one to the other. And it's just another simple metadata mapping to take one set of data and relabel it so that it conforms from one standard to a different standard. So that's kind of my walkthrough of this case study. I hope that you guys found something useful or recognizable in that from context at your own workplaces. And we have about 15 minutes left in the class. So at this point, I want to open things up to questions for not just this session, but from the entirety of the past 5 sessions. I'm happy to go over anything else on the website. I'm happy to walk through the PBCore tool, any of our databases, any of the tools and integrations that we have available for PBCore. Oh, sorry, I realized I did forget one thing when talking through this case study. So before class, Tammy let me know that while she hadn't mentioned this in the write-up she sent me, the tool that they actually use at her institution currently to present their metadata is ArchiveSpace, which I said I was really excited about that because it does give me an opportunity to jump to talking about some of our external tools and integrations for PBCore. So one of the projects that we've been doing over the past couple of years is trying to ensure that a lot of the tools that are used in the real world to manage content have the opportunity to utilize, to make it easier to import and export PBCore metadata. So you can see on this external tools and integrations, we have some information about how to use MediaInfo. We have information about how to export PBCore XML from ProTrack Broadcast Management System, which is a tool that's broadly used in the public archive space. We have PBCore-based profiles to use with Collective Access, which is a software for managing and publishing museum and archival collections. Some of you may be familiar with it. We have a PBCore plugin that was developed for Omeka, the open source web publishing platform. And we do, in fact, have PBSpace, a plugin for ArchiveSpace that adds new properties and object relationships so that PBCore structure, elements, and attributes can be better represented. What PBSpace does to provide kind of additional functionality to ArchiveSpace is it allows the replication of that asset and instantiation level metadata within ArchiveSpace. This, I think, could potentially be exceptionally useful for Tammy's case study, where Tammy is going to be talking about at least two instantiations of all of the content within this collection, because there's going to be the original film instantiation and there's going to be the digital instantiation after that film is digitized. It's also possible, because these 16mm films are potentially, they could be replicated across each other. It's possible that some of these 16mm films could have negative and positive versions of each other. Some of them could be prints of each other. There could be multiple instantiations on different films of the same content. And utilizing that instantiation level view in ArchiveSpace would allow the opportunity to provide detailed technical metadata about both the films and the digital properties on a level below the level that ArchiveSpace that actually discusses the content of those films. So this is something that Tammy, if your ArchiveSpace team is interested in trying out and is interested in seeing how PBCore could be utilized within ArchiveSpace, I'd love to hear how that goes. All right. Now, sorry for that detour, but I did want to briefly talk about, seize the opportunity to talk about some of our tools and integrations available, and you can see more about that on pbcore.org under the External Tools and Integrations tab. And now, let me jump back to what I was saying before and throw it open to questions from you guys. Anything about the past couple of sessions, or anything about problems that you're facing with metadata at your institutions that you'd like me to answer while we're here, or anything else that comes to mind in the last 12 minutes that we have of class.
I have a question about technical stuff that you get from your vendor. How do you add the time to your record? Do you add it one at a time, or do you just dump the whole Excel sheet into your system?
Sure. So we do it on a batch level. We're usually receiving several thousand items at a time. So doing it one at a time would take a lot of time that unfortunately we don't have. So we import, so that spreadsheet that I showed you of metadata we get sent a spreadsheet every month from what our vendor has digitized over the course of that month. Then we import that into this spreadsheet. And so that usually, is a couple thousand records that get imported at a time, which includes this total running time, actual ingested time field, which would map to PBCore duration. That tells us how the file actually, how long the file actually ran for when it was digitized. And that, along with some of the other technical metadata, gets pulled into this, this particular view of the database. So we can actually see what the digitized item duration was. And then if there's something wrong with the proxy that we're playing to do this cataloging, we can see whether it matches the duration of the digitized item. And if it doesn't, then we know there's something wrong with the actual file. I see there's a question in the handout material under Harkness film inventory in the header. What is size 1? Let me jump back to the inventory. I'm not. Oh, what is size? Sorry, misread that question. So this size, I believe, and Tammy, correct me if I'm wrong, represents how the actual dimensions of the reel of film. So if I can jump back to the image that went along with this case study, you see that for a reel of film, you can actually measure it across to see how many inches across that film is, and knowing how, what the actual dimensions of that reel of film are gives you kind of a sense of how long the content is going to be. And there are calculations that you can do, which I don't know off the top of my head, to, if you have a 16 millimeter film or a 35 millimeter film and you know that it's 7 inches in diameter, you can run a basic calculation and say, we estimate that that means this reel of film is going to be so many minutes long based on its diameter. And that means that the vendor can kind of estimate how long it's going to take them to digitize it, because this digitization has to happen in real time, and give you a better pricing estimate based on that. Paul Conway asks, does the PBCore cataloging tool support import of data from a spreadsheet? Absolutely, it does. It is not the most convenient import, but I'll go over it again. We do provide it because we know that a lot of people are cataloging in spreadsheets, and this is actually a kind of a great way to talk about mapping and modeling as well. So the PBCore tool, which I'm going to open up again, just a moment. So the PBCore cataloging tool does support import from a spreadsheet. You can convert a CSV file to XML using the tool. And to do that, you just have to hit convert CSV file to XML. And then you'd select the CSV file that you have, and you would open it, and it would automatically create records based on the rows in that CSV. Now, the kicker there is that in order to work with the PBCore cataloging tool, you have to use the specific version of the PBCore CSV that is designed to work with the cataloging tool. So here you see where it says full PBCore spreadsheet expanded, which represents PBCore to the fullest extent possible in flat spreadsheet format, including multiple repetitions of each repeatable element and all possible attributes. This particular version is designed for use with the PBCore cataloging tool when saved as a CSV file. That's important. If it's saved as an Excel, the tool won't be able to parse it. It has to be saved as a CSV. And as you can see, when we open this full PBCore spreadsheet template, which should open in just a second, it is incredibly long, because PBCore has a lot of potential elements and attributes, and most of those are repeatable and can be used multiple times. And so if you're trying to use PBCore to its fullest possible extent, and if you want to make sure that someone has the opportunity to use PBCore to its fullest possible extent, we're going all the way out to hundreds of fields. So we know that not everyone is most people are not going to be using all of these hundreds of fields. So what we would recommend is creating a spreadsheet that has the specific fields that you want to use when you're doing the cataloging. Simply use, if all you're capturing is title and description and perhaps a contributor or two, create a spreadsheet that just has those fields, so you're not having to deal with this enormous, massive spreadsheet. And then when you've gathered your data, just copy paste it into the associated field. So again, that's you're utilizing mapping. You're saying, all right, my spreadsheet that I'm using at home, at my institution, that I want my interns to understand, and that is kind of clear and uses simplified language, has the fields title, description, and publisher. And then I'm going to go into this big, massive PBCore spreadsheet, and I'm going to take all of the data that I gathered under the title field, and I'm going to look for PBCore title, which is going to be over here, title 1, the first title of multiple repeatable titles. And I'm just going to copy and paste that right into that field so that it can be ingested into the PBCore cataloging tool. If we hide the fields from this template, can we save it and come back to the same configuration, i.e. fields are still hidden? Absolutely. If I hide fields because I don't want to see them, I know that I'm only going to want one asset type, and I'm not going to use any attributes with it. So I can just hide all the other asset type fields. I'm going to hide, and I will save as I'm just going to save it as my desktop, is PBCore cataloging tool spreadsheet hidden. Now I'm going to close it. Then I'll reopen it, and theoretically, again, you always are risking something with a live demo that it won't work exactly as you think it should. I'm going to reopen PBCore cataloging tool compliance spreadsheet. Find it again. Here we go. And it should reopen with all of those fields hidden. Now the kicker there is that this is a tool that hiding fields is a tool that I can use in Excel. It won't work as a CSV. And as a CSV is the way that I need to import it into the PBCore cataloging tool. So when I'm working with it, I would probably continue to save it as an Excel so that I could hide all the fields I didn't want. But then I'd have to remember before importing it into the cataloging tool to save a version as a CSV. And it is, once I do that, it is going to yell at me that some formats are incompatible. And then I'll keep the selected format, save only the active sheet. And it will no longer be, if I open it as a CSV, those fields will no longer be hidden because hiding fields is not something that's doable within a CSV. It's an added feature for Excel. Question, my institution uses Past Perfect, which is not set up for cataloging AV collections in any useful way. Does anyone use PBCore with Past Perfect? Should we look into other databases? That is a great question. I personally have not encountered Past Perfect used with PBCore, but I'd be interested in looking at it more and seeing, what are the ways that it could be incorporated. If anyone else has used Past Perfect for AV collections, I encourage you to chime in the field or in the chat and see if you can help Hannah with her question. And that's certainly, something that I'd be interested in looking into more, because we're always trying to expand our reach for institutions, systems that are currently in use at cultural heritage institutions. So we've got 3 minutes left in the class, which is still enough time to slide in another question or two if anybody has them. But for right now, let me jump back to the last slide on my spreadsheet. And just to go over once again, thank you so much for joining us throughout the course of these sessions. It's been really a treat to talk to you guys. If you've sent me any sample records or worksheets or homework that you'd like me to review and I haven't gotten back to you, please let me know. I think in week 3, I did lose a couple to a spam filter. So if I haven't responded to you and you think that I should have, send me a nudge or send Kim a nudge. And I promise we'll get back to you. Just because the class is over doesn't mean you can't reach out to me with PBCore questions. I will be happy to answer at any point. If you missed any sessions, all of them are available on the course playlist. That's here at nedcc.org/PBCoreRec. Please feel free to share them. They are, they're free and available to access if you want to share them with colleagues or with other people at your workspace. And if they have questions, my inbox is open. I'm always happy to talk about PBCore. Oh, Tammy, do I know of any institutions that have used the PBCore plugin in ArchiveSpace? If anybody's using it, they haven't gotten back to us to tell us about it. So we would love to hear of somebody that actually is using it. Again, if you're here and you are using it or you know of someone who's using it, please let me or Tammy know. We are always excited to hear feedback on it and on how that's working. And Tammy, if you have more questions about the PBCore plugin in ArchiveSpace, I can also, in addition to just talking with you about it myself, I can put you in touch with the developer and with the team at ArchiveSpace that helped us work on it. And thank you again. So we're just about out of time at this point. So thank you again so much for coming. And look forward to answering any PBCore questions that you may have in the future.